Hey, good morning, everyone, or evening, depending on where you're watching it from, I guess. My name's Matt Johnson, and I'm a developer advocate with Bridge Crew, now Palo Alto Networks. And obviously would love to be joining you in person there at DevOps Pro Europe, but with UK travel restrictions as they are, virtual is probably the way to go just for a little bit longer. Anyway, I'm here today to talk to you about all things DevSecOps, about infrastructure as code security. And as you might have noticed, I've not opened any slides, but we're going to try and keep this as kind of hands-on and practical as possible. So let's jump right in. To start with, DevSecOps, like what are we really talking about there? When we talk about infrastructure as code security. So I always find a little bit of context is helpful. Please do use the Q&A ability in the platform to let me know any questions as we go through. I'll try and keep an eye on it, and if questions come up, we can deep dive into them if and as and when they happen. My apologies, just having some microphone technicals here. We're gonna testing. Can everyone hear me now? Okay. I'm not the audience participation I was looking for, but we'll hopefully someone will let me know if they can hear me okay. The Pine Tool platform is telling me it can see my audio, so please do let me know if that's not the case. But I'm gonna carry on. Thanks everyone for the heads up. So it's all well and good being able to deploy, 1, 2, however many times a day using these DevOps tooling, but if security is still not in that pipeline, if security is still a manual process or a separate team or requires, a non-automated validation process to kind of ensure and sign off that new release, then you kind of have to do DevSecOps to realize the value of the DevOps pipelines you put together. Because without DevSecOps, there is still a manual process that you have to go out to, and manual things happen and then come back in to really be benefiting from kind of those pipelines. So put quite simply, DevSecOps is just this idea that we embed the security team from the very start, from the very first line of code, from the very start of a project, just like we would with DevOps. We'd have the people doing the deployment and the people doing the application code with them, on the same team, building that pipeline together. And the DevSecOps is just an extension of that, and just the idea that we should have security teams on board. Now, this is where it becomes slightly tricky because some organizations might not have a dedicated security team to kind of embed with those DevOps teams, and that's okay. You know, you might have like a security advocate, someone more security focused, or with passion in kind of, you know, infrastructure security on your team that can kind of act as that advocate. It's not really about necessarily where the people come from. It's just that mindset of making sure, you know, security tooling in our CI/CD pipelines, rather than expecting that to be a manual add-on from another team. And chances are, you know, with application code security, you're probably already doing a little bit of DevSecOps. You know, chances are you might be running something in your CI/CD pipeline, you know, along with your tests and your unit tests and your integration tests. Chances are you might be running something like GoSec, or, you know, a tool which is designed to look for, you know, vulnerable ways of writing code. So it might be like, hey, you're like execing out to a system binary here based on a user passed variable. That's a very bad idea. That opens you up to kind of remote code execution, you know. So from an application point of view, your application code, you might already be running, you know, third-party tools, open source tools, you know, SaaS services, as part of your CI/CD pipeline to look for those security issues. Now, we can go one step further than that, and we can start doing infrastructure as code security. And that's really where, you know, DevOps and DevSecOps kind of come together really nicely, because if you're doing DevOps practices and following CI/CD pipelines, the chances are you won't have, you won't be manually creating resources in AWS. You won't be manually going and kubectling all of your deployments with the kubectl API just to deploy a pod. You will have a CI/CD pipeline with Terraform or CloudFormation or Helm or Kubernetes manifests somewhere in there, to basically allow you to automate that whole process. And so infrastructure of code security is the idea that just like we have tools that go and look for vulnerabilities in your application code, because that infrastructure is now codified, because it's now in some kind of language that we can store and track in Git, we can now do exactly the same with our infrastructure as code. That look like. So for example, and this is the time I share my screen. If he can find the session, there we go. Here we go. So, like I said, we're gonna jump around between the terminal and my browser, and maybe some VS Code as well. If you can't see this in terms of font size, please do let me know. And again, any kind of questions as we go through that aren't related to sound, although I do appreciate it, let me know in the Q&A session. So we have maintained projects such as TerraGoat. And what does infrastructure as code security look like, for example? We appreciate that not everyone's going to jump in and going to kind of have, you know, Terraform or have things in their production CI/CD pipeline that they want to explore these concepts with. You know, putting a brand new tool into your CI/CD pipeline untested, especially when we've seen with all the kind of you know, tool chain attacks and things. We appreciate that, you know, you're going to want to get a feel for infrastructure as code security if it's a new topic to you. And so this is why we've created the GOAT projects. So here we have TerraGoat, which is purposely vulnerable Terraform infrastructure. So for those of you that have seen Terraform before, this will look familiar. For those not, we'll walk through an example. In TerraGoat, you basically have a load of Terraform as if it was someone's infrastructure as code setup for their deployments. And we have made all the bad choices here. So everything in TerraGoat is designed to be intentionally vulnerable. It is definitely not Terraform we recommend you deploying. But what we will see here is, as you can see for this S3 set of definitions, so we're defining that we want Terraform to create as an AWS S3 bucket. And we've made that bucket public. It's not encrypted. It doesn't have access logs, and it doesn't have versioning. All fairly bad things for an S3 bucket. And you'll see that goes on very similarly as well. Through all the other resources, we have EKS clusters, we have a load of resources for Azure and GCP, and all of them designed to be as vulnerable as possible. So what would usually happen to a piece of Terraform like this? Let's say I did need a new Kubernetes cluster. What would usually happen is this would be a pull request, and this would be a pull request into my infrastructure as code repo, where my CI/CD pipeline would kick off. It would go and run our application tests. It would maybe go and build the new containers for the application that this Terraform was deploying or that this cluster was for. And we'd end up eventually with these objects in our pipeline. Now, at that point, we have multiple different places we can think about enforcing some infrastructure as code security. We have, the traditional kind of Git pre-commits. So we could, just like a developer might check for leaking secrets with Trufflehog or a tool like that baked into their Git pre-commits, we could check before we ever actually commit to a branch or commit to a feature branch, hopefully not committing to main, that we don't have any glaring misconfigurations in infrastructure as code. Because vulnerability is an interesting word when we come to infrastructure as code. So for example, and I'll just go back to a simpler version, a simpler example. So like EC2, or EC2 is a great example because it's such a simple tool. Vulnerability is an interesting word, isn't it? Because vulnerability suggests that some things, like someone can run some like proof of concept exploit code and kind of, find a way in or something. We don't tend to think of vulnerabilities as insecure defaults. And yet actually with most infrastructure as code, that's exactly what we're looking at. And it's exactly how, it's fairly simple to have tools embedded in your CI/CD process that understand the defaults of these Terraform or these CloudFormation objects or these Kubernetes manifests, and kind of highlight those vulnerabilities that you're about to allow yourself to have if you deploy this. So yeah, we're not talking like, oh, there's a vulnerability in the Terraform library. We're not talking anything like that. We're purely saying that by default, and we've got a load of tags here which can be ignored, but if your AWS S3 resource in Terraform looks like this, the defaults that AWS are going to act on that, or the defaults that Terraform is going to act on creating that S3 bucket are going to be insecure. The public read ACL is going to make it public. Encryption isn't enabled by default. You have to turn that on. Access logs aren't enabled by default. You have to turn that on. Versioning isn't enabled. So these things are just insecure defaults effectively, but that still opens your bucket up to, I have no idea who accessed it. I have no idea what file they replaced because I don't have versioning turned on. And also my contents are not encrypted at rest, not even with kind of an AWS key, let alone a customer key. So, anyone with access to that infrastructure, or if the bucket accidentally goes public, I'm not protected from kind of, internal issues. So that's just something, to bear in mind. It's not vulnerabilities per se, but it's just as dangerous to your infrastructure, because a lot of the time as well, like an application security issue you find might affect that application. Like if you deploy an insecure Kubernetes cluster, or the EC2 VMs, to carry on using AWS as an example, or, publicly facing for SSH because of a security group rule that's been set incorrectly, you're not just potentially talking one application. With infrastructure as code, we could be talking everything across, multiple application deployments, which is made insecure by the fact that our infrastructure underneath was insecure. So that's TerraGoat, and kind of gives an example of some of the things to look out for. We also have multiple of these for different frameworks. So if you're a CloudFormation fan, we have CFN-Go, we have CDK-Go, and ORM for the Azure templating style. I'd also like to shout out for the Kubernetes fans among you, the Kubernetes Go here. And this is an absolutely fantastic resource for, learning all things Kubernetes. But it starts off by being an intentionally vulnerable cluster with some intentionally vulnerable application deployments on top of it. So we'll find very purposely vulnerable Kubernetes deployments, just like we found with Terraform for TerraGoat in here as well. And the kind of rise of Kubernetes and the fact that, we can now consider, because that is like an API you get pretty much everywhere. If you ask for a Kubernetes cluster in any major cloud provider, you're going to get it. So this got us thinking, well, okay, like we have to consider Kubernetes as just as much of a IAC framework, an infrastructure as code framework. Yes, people might be deploying with Terraform or CloudFormation or ARM, but they might also be deploying with Kubernetes or Helm. Just because they're at a different level of abstraction, it's still defining your infrastructure as code, because you can define services out to the world, you can define ingress, you can define HTTPS and TLS termination. It is an infrastructure as code framework effectively. And so with that, we started thinking, well, okay, it's easy to look at TerraGoat and go, well, okay, that's purposely vulnerable. You've made that as vulnerable as possible. But as I said, it's not vulnerabilities per se, it's insecure defaults, which put your entire infrastructure at risk. So we went and did some research on what the actual state of public reusable Kubernetes manifests look like. And because it's still kind of 80% market share over other templating languages for creating reusable pieces of Kubernetes, we looked at Helm. So we basically went and researched Helm. We originally started in GitHub by kind of collating and populating any Helm repos we could find across GitHub. We realized that probably wasn't particularly useful because we were finding a lot of old artifacts. We were finding a lot of kind of abandoned or Helm version 2 style charts. And so instead we came to ArtifactHub. And in ArtifactHub, there is the ability to just search for all Helm plugins. And, having used previous versions of Helm where there was kind of that single blessed charts repository in Helm's Git repo that anyone could kind of contribute to, ArtifactHub's done a wonderful job of allowing people to register for an organization and to share their Helm artifacts, even if, they're not all in the same repo. So if we, for example, find Bitnami do, as we found out from our research, some of the most popularly downloaded Helm charts. So, for example, if we wanted a Helm chart for PostgreSQL, we can see it here. Now, this isn't hosted by ArtifactHub, but this is providing Bitnami the ability to list these all in an automated way here, and then kind of list how and where you would get their charts from their chart repo. So, for example, for this chart here, we could obviously add it with the Helm CLI, or we can even just download a tar.gz with that brand new version of that chart if you want a local copy. So, and what's interesting is all this through ArtifactHub is also available through APIs. So we actually took ArtifactHub and we wrote some currently very POC code. But the idea was we went and downloaded every single Helm chart in ArtifactHub at the time of release. So about a week ago when we released the report. And we basically took every single Helm chart and then we stored metadata about that Helm chart, the Helm chart's dependencies on other Helm charts, where it's from, what repo it's from, linked to ArtifactHub, the version, et cetera, et cetera. And then we went and we ran our open source security scanning tool, Checkover, which we'll introduce hands-on in a moment, across every single one of those Helm charts to produce a set of data on, how many of these Helm charts by default with the default values, let's say you don't go and go, yep, I want to customize that value, I want to pass extra values into there. If someone just downloaded that Helm chart and deployed it to give them Postgres, for example, what does that look like from a resultant Kubernetes manifest? And so we compiled all of that data. The Helm scanner basically spits out a load of CSVs that we piped into AWS QuickSight. And within AWS QuickSight, let's see if we can, give me a sec. And within AWS QuickSight, we modeled that data. Just gonna move a couple of these off screen. And so we modeled that data, and you can actually read all of our distilled thoughts on that in a 3-part blog post. It became kind of too long to really release as a report. So we split it down into 3 blog posts, which are all live and are all linked from the README of the Helm Scanner repo as well. And so what we actually found was, very similar to kind of our gut feel that there is going to be a lot of insecure defaults. So, and the reason for this is hello world isn't necessarily hello world if you're having to set, TLS certificates and self-signed certs and, ensure a root of trust and, all that kind of stuff that goes with security. If someone is trying to make a Helm chart super simple to comprehend and super simple to run, that's a lot of items that are maybe going to make that more complex. And so we do find that the default configuration of a lot of these Helm charts is, is kind of oversimplified and leans to the more insecure defaults rather than the secure defaults. So as you can see from the post, we scanned 2,300 plus Helm charts across 600 registered repositories within ArtifactHub. And the way we scan those Helm charts is with Checkov, which again, we might as well jump in and introduce. I've just created myself a new pipenv just to keep everything nice and tidy. So I'll just jump into that new pipenv. There we go. And then it's super simple to install Checkov. So pip install Checkov. You can also brew install Checkov for Mac fans. And that'll go away and grab some dependencies. So we'll come back to that in a minute. So yeah, what we did is we basically took all of these repos and we automated with Helm Scanner, passing them through our Checkov tool. And so, like I said, this generated a massive data set because what Checkov allows us to do, it has built-in policies for a lot of different infrastructure as code frameworks, including Helm, including Kubernetes, and like I've already covered, CloudFormation, Terraform, ARM templates, serverless templates. And so we are looking for those common misconfigurations. We're looking for those insecure defaults. We're looking for, pretty much anything we can highlight against kind of the CIS guidelines, for example, Kubernetes, or CIS guidelines against AWS, as well as some other, we've written those policies based on the community, but also based on like PCI DSS and kind of common security guidelines. So let's see how we're doing with Checkov. There we go. Once we have Checkov installed, you can see that Checkov on its own, there we go. We have multiple options, but at its heart, it's a super simple tool, and it will go and find any infrastructure as code resources that it can across any of the supported frameworks, and will evaluate those against the built-in policies. Now, the built-in policies are kind of one of the, the most kind of commented useful feature of Checkov. We don't make you go and download Checkov and then find a policy pack somewhere. Every new version of Checkov just has new checks embedded within it. So we're currently up to 1,134 checks within Checkov, which is insane. And these cover everything from Kubernetes, Terraform, across different cloud providers, CloudFormation, et cetera, et cetera. So I just did -- list there, so you can get a list of all the checks. And you can also say, look, hey, Checkov, I'm actually only specifically interested in a a certain framework. So you can tell it only to try and find Terraform or Kubernetes or any of our supported frameworks. And you can also bring your own checks. Do go check out checkoff.io. We support 2 different languages for writing checks, a kind of YAML style policy definition, and also just writing checks directly with Python with some helper scripts built into some helper functions built into Checkoff. So it is really easy to bring your own check. And even if you don't want to contribute those back to Checkoff itself via a pull request, which we more than accept, by the way, you can load in your own set of custom checks from an external directory, for example, in a CI/CD environment, or from Git. So what we were doing with the Helm data to generate that, in fact, let's go into TerraGoat, which I've already checked out from showing you on GitHub earlier. So we have a copy of, Kubernetes Goat. Let's go and look at Kubernetes since we're looking at Helm. And by default, if I just run checkoff-d dot, that is going to go and recursively look through your local directory on your current path, and it's going to go and try and find anything that looks like our supported frameworks, and it's going to give you any insights it finds, including any past checks. And so what you'll see here, because we are on a purposely vulnerable repository TerraGoat, we found a lot of issues. So some of these differ in priority to others. But for example, this is in the CIS 1.6 guidelines. And so here we're basically saying this piece of configuration, this piece of Kubernetes, the container should be running as a high UID, so that if there is a container escape, that user's process that they've escaped from that container isn't then running with a UID that actually matches something on the real underlying system. You know, we see this all the time with root containers. If you're root within a container and you find a way of breaking out of that container, you are still root on the underlying host. So to save that, make sure your container is running with a high UUID. Another example here, we can't see any security context. We can't see any, reduction of capabilities. We aren't by default unmounting the default service tokens that you will get for a lot of Kubernetes deployed objects. This one can kind of be ignored in a Helm context, and we cover this in the blog because Helm is going to take care of creating as a new namespace anyway. But then you'll see there's a lot of past checks. So we've clearly found Docker files in this repo as well. So we're checking in the Docker files that kind of port 22 isn't exposed, that the base image isn't just using latest, because if you're using latest, you've kind of no deterministic nature within, yes, your CI/CD infrastructure deployments are in Git, but at the same time, you've no deterministic nature as to which container got deployed. Like if it always just says latest in Git, how do I know 4 weeks ago on Sunday which version of the container I was running? So it's much better security practice to specify the tag, or even better, the Git, the SHA hash of a container image, because obviously hackers with access to a container registry can actually move those tags around, whereas a SHA hash will always be immutable. So that's probably the best way of knowing exactly which container you're running as part of your manifests. So, and if we weren't interested in, any of these checks, for my apologies, if we weren't interested in any of these checks for Docker, we could go Helm, and at this point we are purely saying only scan things that are Helm charts, which we should find a couple of within this framework as well. And you'll see, interestingly, if I do framework Helm and I then do framework Kubernetes, the results will be different, but you'll see the actual checks we're running will be of the same naming format. And that's because the way that Checkov scans Helm charts by default, and you can see there's a lot more for one than the other, but the way that Checkov scans Helm charts by default is we template out that Helm chart into Kubernetes, and then we run it against our built-in Kubernetes checks in Checkov. these checks doesn't really make sense. You kind of want to compare them against the underlying resultant configuration, which is Kubernetes. You see here a very important one. We really shouldn't be using stars in our RBAC roles. So yeah, that would be a good one to catch. For example, if it was inside a Helm chart by default, which it was, and if you're just consuming that Helm chart, you're going to be opening yourself up to potentially hackers with access to one item across the cluster. So that's kind of Checkov in a nutshell. And so just going back to the Helm point, we use Checkov against all of these repos, against all of these Helm charts, just to kind of have a look at this default security posture. And so what we found was, yeah, like loads. Hey, sorry about that, everyone. What are the chances? Symmetric, gigabit, Ethernet, internet connection, and that's the first time it's died in about 4 years. So perfect timing as always, and apologies. And in debugging, I managed to close down pretty much everything I was doing browser-wise as well. So I know we've only got 5 minutes left. I'm going to try and make it action-packed. So thanks for sticking with me, and apologies for the technicals there. So let's have a quick look here. So we were talking about TerraGoat, and we were talking about ArtifactHub being a great place to find Helm charts, but they might be, insecure by default on occasion. And we were talking about Checkov, which we still have open in this terminal here. So what I had done just beforehand is I had run Checkov against our Kubernetes Goat repo, and we showed how we can do framework to pick a specific framework if we're interested. And we'd also showed how the way we scan Helm charts is we template them out to Kubernetes, and then we scan Kubernetes. And there's a benefit to doing that. Not just we have one set of policies that work in both places, but we can also compare the issues we find on a Helm chart by scanning the chart with the issues we find by pulling the actual running manifest of that pod or that deployment off the cluster. And we can kind of check that, issues that we fixed in the Helm chart are still fixed in the cluster, et cetera, et cetera. And so I just want to give you some kind of hands-on useful information here to close out. That's really what this session is all about. I will put the Helm Part 1, and from there you can find Part 2 and Part 3 link in the chat here. There we go. And also a link to Checkov.io. So, Checkov basically allows us via this open source tool to implement a lot of these kind of security checks that your security team might not be aware of. You might not have a dedicated security person. What should you or what can you be doing with that? And how does that benefit you? Because like I said, there's multiple places we could run this. So you've just seen me run this locally, and yes, I can run it against Kubernetes. I can run it against TerraGoat to give an idea of some of the issues we find there as well with Terraform. But this is all well and good, but a developer just running this themselves manually isn't solving all of the problem. If I forget to run this, I might still be committing vulnerable code. So it really is important to have kind of things like this. As we say, we need to automate this process. We need to put this directly into our CI/CD pipeline. And there's a few ways we can do this. So Checkov by default is designed to, and you can skip checks using some of the options. Checkov by default is designed to fail if we find errors. So you can see our return code on the shell is 1. So you can embed this absolutely fine in pretty much any CI/CD pipeline you can think of. In fact, if we have a look, we already have examples, and I'll link this as well, for GitHub Actions. So we have a drop-in GitHub action, which allows you to make sure Checkov is part of your pipeline. Let's have a look if we can find it. Yeah, so the code base is there. And so let's go and find this on GitHub Marketplace. So there's the code, and as you can see, it's a single click install, and you can just drop this with any configurations you want into your existing CI/CD pipelines. Same with if you're using like AWS code build, code run, we have examples of how to deploy it into there as well. But because it is just a binary that fails with issues, you can obviously pretty much put it wherever you want. We also support different output formats. So if you wanted to do kind of post-processing on this data and the kind of default configuration isn't particularly useful, you can see here, we can output in JSON with all the passed and failed checks for further processing. And then the last thing I wanted to just quickly highlight is if today you are going, okay, well, I am using Helm Charts, like how do I make sure they are secure? Like I said, you can just scan anything. So remember the PostgreSQL Helm chart we downloaded? What we can do is we can extract that Helm chart. So I have that here, just extracted the tar.gz. I can change to downloads, whatever that was called. Yeah. And then I can do a check of on that. It will find the Helm chart. It will template it out to Kubernetes. Whether you're doing this in CI/CD or whether you're doing this in local, is super useful for your security posture. Definitely give it a try. Definitely see what you find on your local infrastructures. Sorry about the technical issues. And if anyone does want to follow up with me, I'm either here in the Slack or you can find me at MetaHurt. And yeah. Appreciate it. Cheers.